Hello everyone, in this video we're going to explore topic 9.7 defining polar coordinates and differentiating in polar form. Alright, so half of this topic you already learned in AP Pre-Calculus. Alright, so go ahead, review some concept in AP Pre-Calculus. Alright, first we're going to talk about the test for symmetry. I have the video about this topic. Alright, please check out the link in the description below. It's going to be right here. The second one we're going to talk about graph of polar equations of circle. Alright, I have the link right here. And I also have the link in the description below. Number 3, we're going to talk about the graph of Limacon curves. Number 4, we're going to talk about the graph of Rolle's curves. Number 5, we're going to talk about the graph of Lemniscate curves. Now let's move on to sample number 1. Graph each point. You have this one is the polar coordinate, which is radius and angle theta. Alright, so this one is the polar axis, right? And this one is the initial rate. Now if you go counterclockwise direction, the angle is positive. If you go clockwise direction, the angle is negative. The first thing you need to do is to sketch the angle, right? So the angle right here is 7 pi over 6, which is theta is 7 pi over 6, right? Since 7 pi over 6 is positive, right? Then you need to go counterclockwise direction, right? So this one is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6 right here, right? The radius is negative 1.5. Now you only use 1.5 right here, right? So 1 is the first circle right here, right? 1.5 is going to be right here. The distance from here to here, right? Now, since the radius is negative, so you need to take the opposite right? So opposite to this one is this guy right here. So this one is the point of this guy, right? Now, second one, the angle is negative pi over 3, right? So you need to go clockwise direction, right? So negative pi over 3 is right here, right? And the radius is 2, so should be 2 circle, right? So it could be right here. This one is the coordinate of this point. Now let's move on to the next one, coordinate conversions. We need to convert from polar to rectangular coordinate, right? We know that x equals r cosine theta and y equals r sine theta, right? How do we get this formula? We just use trigonometric ratio in the right triangle, right? The angle theta right here, radius is right here. This one is the s, this one is the y, right? Remember, you have sine of angle theta equals opposite over hypotenuse, right? Cosine of angle theta is going to be adjacent over hypotenuse, right? So that's why you get this one right here. And then you convert to this guy, right? Now let's take a look at example number 2 right here. Convert the following polar points to rectangular points, right? So the radius is 2 root 3 and angle theta is pi over 6, right? So you have s equals r cosine theta, which means 2 root 3 cosine pi over 6, right? Now cosine pi over 6 equals root 3 over 2, right? So it could be 2 root 3 times root 3 over 2, right? 2 and 2 cancel out. Root 3 times root 3 equals 3, right? Now y equals r sine theta, right? So it could be 2 root 3 times sine pi over 6, right? Sine pi over 6 equals 1/2, right? So it could be 2 root 3 times 1/2, right? 2 and 2 cancel out, so it could be root 3, right? So you have the order pair s first 3 and then y root 3, right? Now let's move on to the second one. You have the radius is 8 and angle theta is 5 pi over 4, right? So s equals 8 cosine 5 pi over 4, right? So it's going to be 8 times cosine 5 pi over 4 is negative root 2 over 2, right? So the answer is negative 4 root 2. Now y equals 8 sine 5 pi over 4, right? So it could be 8 times sine 5 pi over 4 equals negative root 2 over 2, right? So the answer is negative 4 root 2, right? So you have the order pair negative 4 root 2, comma, negative 4 root 2, right? Now, next one, we need to convert from rectangular to polar coordinates, right? So again, we have the Pythagorean theorem, x squared plus y squared equals r squared, right? This one plus this one equals this one, right? And then you have the tangent theta is going to be opposite over adjacent, right? So it could be y over s right here. So you're given the order pair s and y. You need to convert this one to radius and angle theta, which is the polar form, right? So you need to find the radius and angle theta. To find the radius, you're going to use this formula. To find angle theta, you need to use this formula, alright? Now, to find the angle theta, you need to pay attention to following cases, right? Alright, so look at example number 3. You need to convert this one is s and this one is y, right? So you need to convert this one to r and angle theta, right? So you have r equals square root of s squared plus y squared, right? So it could be square root of 9 plus 9. So it could be square root of 18, right? So it could be 3 root 2, right? Now angle theta is inverse tangent of y divided by s, right? So it could be inverse tangent of negative 3 over 3, right? So it could be inverse tangent of negative 1, right? And this guy actually negative pi over 4. Now since s positive, y is negative, so it's going to be case number 4 right here, right? Then you have angle theta is going to be 2 pi minus absolute value of negative pi over 4, right? So it could be 2 pi minus pi over 4. It could be 7 pi over 4, right? Alright, so your answer is 3 root 2, comma 7 pi over 4. Alright, question B. Radius is square root of negative 4 square is to be 16, right? This guy square is to be 48, right? Equals square root of 64 and it's going to be 8, right? Now angle theta equals inverse tangent of absolute value of y divided by s is to be 4 root 3 divided by 4, right? So it's going to be inverse tangent of root 3, right? And it's going to be pi over 3, right? Now you have s negative, y positive. It's going to be this guy right here, right? So then the angle theta should be pi subtract this guy right here, pi over 3, right? So it could be 2 pi over 3, right? Then you have the final answer is right here, 8 comma 2 pi over 3, right? Now let's move on to the next one, equation conversions. You need to convert the following rectangular equation to polar equations. Alright, verify by graphing both on the TINs by using two different graph pages, right? So y equals 6. You know that y is sine theta, right? So it could be r sine theta equals 6, right? So r equals 6 divided by sine theta. And this one is the polar equation, right? Now 6 over sine theta is the same thing as 6 times cosecant theta, right? Now let's move on to question B. You know that s equals r cosine theta, right? So I have 4 times r cosine theta minus 2 y equals r sine theta, right? R sine theta minus 1 equals 0, right? Now I'm going to add 1 both sides and then I'm going to factor r out, right? So I have r times 4 cosine theta minus 2 sine theta, right? Equals 1. So r equals 1 divided by 4 cosine theta minus 2 sine theta, right? Now let's move on to question C. You know that y equals r sine theta, right? Equals 4 times r cosine theta altogether squared, right? So this one turns out to be r sine theta. This one square and then subtract both sides, so it will be 4 r square cosine square theta equals 0, right? Now I'm going to divide both sides by r, so it will be sine theta minus 4r cosine square theta, right? So I need to solve for r, so it will be r equals sine theta over 4 cosine square theta, right? Now, example number 5, we need to convert the polar equation to rectangular equations. Now, r equals negative cosecant theta. So this guy is the same thing as negative 1 over sine theta, right? We need to use the formula s equals r cosine theta and y equals r sine theta, right? So I'm going to multiply both sides by sine theta, so it can be r sine theta equals negative 1, right? So r sine theta is actually y, right? So y equals negative 1. This one is the final answer, right? Now, question B, I'm going to multiply both sides by denominator, right? So it's going to be r sine theta plus 3r cosine theta equals 2, right? R sine theta actually y plus 3s equals 2, right? Or y equals negative 3s plus 2. This one is the final answer, right? Now question C. I'm going to multiply both sides by denominator, right? So I have r plus 2r cosine theta equals 3, right? Now, remember you have r squared equals s squared plus y squared, right? So this is r, you need to take square root both sides, right? So it could be square root of s squared plus y squared, right? Plus 2 r cosine theta, this guy actually s, right? Equals 3, right? Now, it could be s squared plus y squared equals 3 minus 2s, right? Now, I'm going to square both sides. So it could be s squared plus y squared equals 3 minus 2s all together square, right? I'm going to use complete square formula to expand the right hand side, right? So I have s squared plus y squared equals 9 minus 24s plus 4s squared, right? Then I need to solve for y, right? So y squared equals 4s squared subtract s squared, it could be 3s squared minus 24s plus 9, right? Now I'm going to take square root both sides, so y equals plus and minus square root of 3s squared minus 24s plus 9, right? Now, next one, we need to convert the polar form to the parametric form using this one, right? You have s equals r cosine theta, r equals 4, so it could be 4 cosine theta, and y equals 4 sine theta. That's it, right? Now, question B, s equals r cosine theta, but r equals this one, so it could be 4 sine theta cosine theta, right? And y equals r sine theta, so it's going to be 4 sine theta square, right? Now question C, you know that s equals r cosine theta, right? But r equals this one, right? So I have 4 over cosine theta times cosine theta, so it could be 4, right? Now y equals 4 over cosine theta times sine theta, right? Right, sine divided by cosine, it could be tangent, so it could be 4 tangent theta, right? Now, let's move on to the polar graphs. Example number 7, we need to graph polar equations. Now, question A, r equals 2. So the radius equals 2, which means you're going to focus on the second circles, right? So it could be this guy right here. Now, question B, angle theta is pi over 3, right? So pi over 3 is right here, right? So it should be the straight line like this. Now, question C, r equals secant theta. Secant theta equals 1 over cosine theta, right? And we multiply both sides by cosine theta, so it will be r cosine theta equals 1. But r cosine theta actually s, so s equals 1, right? Now to graph this one, it should be a vertical line, right? So it could be something like this. Now let's move on to example number 8, graphing polar equation. This guy actually the Rose curve. Please check out the link in this description below to know how to graph a Rose curve. Now let's move on to the next topic, slope and tangent lines. To find the slope of the tangent line to a polar graph, consider a differentiable function defined by r equals f of theta. Alright, and don't forget the parametric equation of the polar form is going to be this guy right here. S equals r cosine theta and y equals r sine theta, right? Now I substitute f of theta for r into this parametric equation. So then I get this guy right here, right? Similarly, I get this guy right here, right? Now, using parametric form of dy over dx given in the previous session, you have dy over dx. This one can be written as dy over d theta divided by ds over d theta, right? I just divide the top and bottom by d theta. That's why I get this one, right? Now, dy d theta, this guy actually derivative of this guy with respect to theta, right? So I'm going to use the product rule, right? So u times v prime is going to be u prime times v plus v prime times u, right? So this guy turns out to be f prime of theta times sine theta, right? Plus cosine theta f of theta, right? Over derivative of this one right here with respect to theta, right? So it could be f prime of theta cosine theta minus sine theta f of theta, right? That's why you get this formula right here, right? Now, to find the horizontal tangents to the polar graphs, we just set the numerator equals 0 and denominator different from 0, right? So this guy equals 0, this guy not equal to 0. To find the vertical tangent to polar graphs, we need to set denominator equals 0 and the numerator not equal to 0, right? If ds over d theta and dy over d theta are simultaneously 0, we can make no conclusion about tangent lines, right? So be careful. Now, example number 9, consider the cardioid described by the polar equation r equals 1 plus sine theta. Find the slope of the tangent line to the cardioid when theta equals pi over 3, right? So, you know that S equals R cosine theta, right? But R equals this one right here, right? So I have 1 plus sine theta times cosine theta, right? And Y equals R sine theta is going to be 1 plus sine theta times sine theta. This one right here I can distribute, so it could be sine theta plus sine square theta, right? Now, dy over ds is the same thing as dy over d theta divided by ds over d theta, right? Dy over d theta, we're going to use this function right here, right? So it could be cosine theta plus 2 sine theta cosine theta, right? Over ds over d theta, we're going to use this one right here. So we're going to use the product rule, right? So it could be cosine theta times cosine theta, right? Minus sine theta times 1 plus sine theta, right? Now I'm going to simplify the top. I'm going to factor cosine theta out. It's going to be 1 plus 2 sine theta. I'm going to multiply this one, then distribute this one, right? So it's going to be cosine square theta minus sine theta minus sine square theta, right? I need to evaluate this one as theta equals pi over 3, right? So I put theta equals pi over 3 right here, right? So I have cosine pi over 3 equals 1 half, right? So I have 1 half right here times 1 plus sine pi over 3 equals root 3 over 2, and then simplify 2 right here, it's going to be root 3 left, right? Over cosine pi over 3 equals 1 half square equals 1 over 4, right? Sine pi over 3 equals root 3 over 2, right? So minus root 3 over 2. Now, this one root 3 over 2 square is going to be 3 over 4, right? Alright, so it's going to be 1 plus root 3 over 2 over. The bottom right here, I need to write this guy in the same denominator, right? So 1 4 minus 3 4 is going to be negative 1 half, right? So it's going to be negative 1 plus root 3 divided by 2, right? So the answer is negative 1. So the slope is negative 1, right? Now question B, find the values for the angle theta for which the cardioid tangent line is horizontal or vertical, right? Now first we're going to talk about the horizontal tangent line. Alright, so basically the numerator equals 0, right? This one right here equals 0, right? So it could be cosine theta plus 2 sine theta cosine theta equals 0. Now I'm going to factor cosine theta out. So it could be 1 plus 2 sine theta equals 0, right? So this one is the 0 product, right? So I'm going to let each of this one equals 0. Now this guy turns out to be cosine theta equals 0, theta equals pi over 2, 3 pi over 2. Suppose the domain is going to be 0 to 2 pi, right? And this one turns out to be sine theta equals negative 1 half, right? So theta equals 7 pi over 6 and 11 pi over 6. Now, if you're not strong at trigonometric equation, please check out the link in the description below to review concept in AP pre-calculus. Now let's move on to the vertical tangent line, which is denominator equals 0, right? So denominator is this guy right here. Alright, so I have cosine square theta minus sine theta minus sine square theta equals 0, right? So I have cosine square is going to be 1 minus sine square theta, right? Minus sine theta minus sine square theta equals 0. I need to rewrite this equation as the quadratic equation, right? So negative sine square minus sine square, it could be negative 2 sine square theta, right? Minus sine theta plus 1 equals 0. Multiply both sides by negative 1. So it could be 2 sine square theta plus sine theta minus 1 equals 0. Right? Now consider sine theta as the variable. So this one turns out to be quadratic equation with respect to sine theta. Right? So I'm going to factor this one out. Right? I'm going to use as method right here. Alright, so you need to find two integers multiply equals a times c, a equal 2, c equal negative 1, right? So it could be negative 2. And add up to b, b equals 1 right here, right? So it could be 2 and negative 1, right? So you have sine theta plus 2 times sine theta minus 1, right, equals 0. Now you need to be careful with this method. Since the coefficient right here is 2, right, you need to divide the constant right here by 2, constant right here by 2, right? So I have sine theta plus 1 times sine theta minus 1 half equals 0, right? So this one is the zero product, right? So sine theta plus 1 equals 0, sine theta equals -1, right? And then theta equals 3 pi over 2, right? The second one, sine theta minus 1/2 equals 0, sine theta equals 1/2, right? Then theta equals pi over 6 and 5 pi over 6, right? Now let's move on to the last example, example number 10. Particle motion of a polar curve. A polar curve R is given by R equals theta plus cosine theta, where theta between 0 to 2 pi. A particle is traveling along the polar curve R so that its position at time t is s of t, y of t, and such that d theta over dt equals 1/2. Find the s over dt at the instant theta equals 5 pi over 6 and interpret the meaning of your answer in the context of the problem. Alright, so we know that s equals r cosine theta, right? Then r equal this one, right? So I substitute this one for r, so it could be theta plus cosine theta times cosine theta, right? Now you need to take the derivative ds over dt, right? It's going to be derivative of this one is going to be d theta over dt minus sine theta d theta over dt, right? Times cosine theta, right? I'm going to use the product rule u times v, right? Now plus derivative of this one is going to be negative side, right? So I put negative side right here, d theta over dt times theta plus cosine theta, right? Now I need to evaluate this one as theta equals 5 pi over 6, right? So this one is 5 pi over 6. Alright, so I have d theta over dt is going to be given right here, 1/2 minus sine of 5 pi over 6 times 1/2, right? And the whole thing times cosine 5 pi over 6 minus sine 5 pi over 6 times 1/2 times 5 pi over 6, right? Theta right here equal 5 pi over 6 right here, right? Plus cosine of 5 pi over 6. Now I'm going to simplify 1/2 minus sine 5 pi over 6 is going to be 1/2, right? 1/2 times 1/2 is going to be 1/4, right? Cosine 5 pi over 6 is going to be negative root 3 over 2. Minus 1/2 times 1/2 is going to be 1/4, right? Times 5 pi over 6 minus root 3 over 2, right? I'm going to simplify this one. 1/2 subtract 1/4 is going to be 1 over 4 times this one is going to be negative root 3 over 8, right? Now I just distribute this guy, it's going to be negative 5 pi over 24 plus root 3 over 8, right? So it's going to be negative 5 pi over 24. Now, we need to interpret this guy in the context of the problem. So we need to say that ds over dt equals negative 5 pi over 24 represents the horizontal rate of change of the particle as it's traveling along the polar curve at angle theta equals 5 pi over 6. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher.